we are going to be looking at how to administer virtual networking. So what are some of the things we need to at least look at today? At the end of the day, or let's say in this learning objective, we're going to look at how to configure virtual network, how to configure network security group, and how to configure Azure DNS. Like I've said the other time, I told you guys, everything that we've done in the fundamental course is what we are still repeating. But here, we are going to deep dive into each of those technologies. We just, during the fundamental course, we talked about virtual machine, virtual network, we talked about network security groups, and we talked about the Azure DNS. So let's take a look at this. Now, let's start with how to configure virtual network. So what are some of the things we'll be looking at? So what is virtual network? So you guys know, just the normal on-premises network that we have, where you guys have some cables, some devices that we call router, switch. But most of us, because we are end users, you only know, there is a cable that you plug to the wall. You plug the cable to the faceplate, which is, the name of the device on the wall. So that faceplate is connected to what we call a patch panel. Then from that patch panel, we connect it to a switch. From that switch, we connect to a router. And a router is what, is the device that assign IP addresses to each devices that have been, connected on that network. But you guys might not even see all this. The good thing is we now have, instead of having this patch panel, faceplate, switch in our network, we can just have a router and a Wi-Fi, being connected to our device, like our phone, our laptop, which is what we use, in our personal homes. But in the office environment, you might still have all these devices being set up. And that is the way it is in the data center. So yeah, we are not seeing what's actually in the data center, but that's what would be in the data center. However, we are only leveraging on the virtual, the virtual network. We don't care about, what are some of the devices that have been put in place to make this network work. What we care about is every maybe virtual machine that we spin up, or every other resource that we spin up that needs a network. We just want to spin up a virtual network and attach that network to that resource. And that's what we care about. So here we'll be looking at how to plan our virtual network. How do we even create virtual network? How do we create subnet? I told you guys that for each virtual network, you need to, subnet it. Maybe that might not be the right word. So you need to divide it into chunks. And by dividing it into chunks is what we call subnetting. So when we create a resource, you cannot just assign the resource to the network or assign the network to the resource anyhow it is. You need to create, you can only assign, the resource to a subnet. That means you need to segregate, or you need to divide your network into chunks before you can start assigning resources on them. And that's why we have the subnetting. Then we'll look at how to plan our IP addressing. We'll take a look at that. We'll take a look at the public IP address, the private IP address, and maybe a demonstration on how to create all these resources. So let's start talking about virtual networks. What are virtual networks? Like I've actually explained just the normal network that we have on premises. However, this is a logical representation of that network we've talked about. And that's what we have. That's what we call virtual network. So for each virtual network that we create, it's actually dedicated to the environment that we've created that virtual network from. So if I create a virtual network in my own environment, you will not have access to it. And all the resources within my tenant, or all the resources within that my subscription can be assigned to, that virtual network. So I can actually associate that virtual network with the resources, within my tenant. You will not have access to it except if we create a connection. So we'll talk about how to create this connection and the like. Then you can see we have a virtual network. Before you can start, this is a virtual machine. But before your virtual machine can make use of the network, we need to create a subnet. So you can see the virtual machine is actually within the subnet, and the virtual network actually encapsulates the subnet and the virtual machine. Now you can see what we call the NIC. Back in the day, even during our secondary school, I'm sure most of us might have heard of what an NIC is. An NIC is just the network interface card. So this is where we associate network to on our virtual machine or on our machine, be it a physical machine that you have, be it the virtual machine that is actually in the data center. We associate our network on our virtual machine or on our machine, via the network interface card. So we'll take a look at some of the resources and where do we associate, our IP addresses to on these resources. So we'll talk about the load balancer, the application gateway, and some other resources. So for a virtual machine to pick up, maybe an IP address, we need what we call a network interface card. So here you can see this is a virtual network that has been created in Azure, and we created a subnet, and within that subnet we can start assigning or we can start adding, resources. Now you can see we have our on-premises environment, and we can extend this virtual network to our on-premises environment. How do we extend this? How do we do this? How do we achieve this? This is something we've talked about in the previous course, where we talked about the VPN, virtual private network. So we talk about the P2S, which is the point to site. We talk about the S2S, which is the site to site, and we talk about the ExpressRoute. So we are going to be looking at all those different VPN configuration within this course also. So for us to be able to extend our virtual network, so when we say we extend, that means we want to connect the resources on our on-premises environment with the resources on or in our Azure environment. So a network, let's even take it back to the layman definition. What's a network? What's the purpose of having a network? It's just for us, it's for devices to be connected together. So for us to be able to connect our devices together, for devices to be able to talk to each other, we need what we call a network, and that is it. And that's why you would see that back in the days when you are in the office and you are trying to connect to the server, if there is no network, or let's say if there is no connection between those two devices, then there won't be any interaction. So network is not only what we use to connect to the internet. Even the connection between two devices without connecting to the internet is called a network. And that's why we are going to be talking about the private network. We're also going to be talking about the public network. So when we talk about the public network, we are talking about connecting to the internet. And when we talk about the private network, these are, network to connect devices within our organization. And that's the same thing that we have, on the Azure portal or in the Azure environment, where we have all resources talking to each other within our private network. And if there is a need for these devices to now talk to another device maybe in another organization or to the internet, or we want users to be able to access website that has been hosted in our virtual machine or in our app service. So then we need to have what we call the public network. We need to open that device to the internet, and that's where the public comes in. So yeah, so when we extend, like I said, we use what we call a VPN to extend. But we'll talk about what are some of the devices that needs to be in place for this VPN to work. So what are some of the processes that we need to do or go to, to have what we call the point to site? When we talk about the point to site, we are talking about a particular system. Just this my system. If I want to connect this my system with our virtual network in Azure, then that's what we call a point to site. This is just a system, and that's a point. Or if we want to connect our on-premises environment, like our office environment, and the Azure environment, so that when you go into the office, you do not need to start connecting to any VPN again. There is a connection already, between maybe our office devices and the devices in Azure. So when you go into the office, since you are actually on the office network, you will have access to, the virtual resources in Azure. And that's the site to site. Then same thing goes with the ExpressRoute. The only thing is ExpressRoute doesn't go over the internet. This is actually a dedicated connection between your office environment and the Azure environment. So we'll look at all these ways, to connect or to extend our virtual network in Azure to our on-premises environment. So, and that's what these guys have talked about, enable hybrid cloud scenarios, securely extend your data center with virtual network. So how do we even create our virtual network? Just the same way you create your resource, I'm sure you guys have been able to create one or two resources in Azure, maybe a virtual machine or storage account also. So these are some of the things, these are some of the tabs that you'll be presented with. The basic tab, maybe the networking tab, the tag tab, the security tab, depending on what resource you're creating. And on the basic tab, you will see, this is just a tab where you put in maybe names, what are the SKU, maybe the size, or maybe the type you want to create. Is it premium? Is it standard and the like? So, or the region, as you can see, the resource group. What subscription are you deploying this to? So, to create a virtual network, this is just like creating the other resources, like we've said. And one of the things you need to do when you are creating a virtual network, or you need to make sure, is you need to, when you are planning the IP address that you want to assign to that virtual network, make sure no other IP address in the organization is the same with that IP address you are trying to create, be it on your on-premises environment or in the Azure environment. There is a reason for this. I just explained the fact that we can extend our on-premises or our virtual network in Azure to the on-premises environment. What we are trying to prevent is what we call an overlapping. So when you have two address space, so when you create your network, you'll be presented with what we call an address space. And within this address space is where you have all these different IP addresses. So if you check your phone cannot connect to the internet if no IP address has been assigned to your phone. If you check your system, if there is no IP address assigned to your system, you will not be able to connect to the internet. So we have what we call the address space, and within this address space, devices are actually, picking IP address from that address space. That's why sometimes you will connect to the internet and you see your IP address maybe will be 192.168.1.2, and the next time you are checking again, it has changed from .1.2 to .1.50. So, but it's still within that address space. So that's what we call address space. Now, that means within that particular space, any devices connecting to that network must pick an IP address between, the address space that you've actually created. So make sure that you do not have two address spaces, overlapping, maybe be it in the cloud or be it on the on-premises environment. And that's what some of the thing, some of the prerequisites. It doesn't mean it will not deploy. However, when you want to do maybe what we call VNet to VNet connection, which we call VNet peering, or you want to extend your network to your on-premises environment, you will start having issues. You will not be able to do it because of the fact that you cannot connect two overlapping network address or network together. So you might need to start deleting or reconfiguring at that particular time, which is why we always make sure that when we are connecting or when we are creating our virtual network, the address space should not overlap. And what do we even mean by that? Here, I've created, a network, and within that network, you can see we have different subnets. So you can see there's subnet which is 0.0, another one which is 1.0, 2.0, 30.0, 3.0. You can see, even within that network, you cannot have two subnets overlapping. So you need to give them different address space. And this is what we call, address space. Don't worry about this thing. Here, it is, maybe for people that, have done something related to networking, you might understand what we mean by all this /24/24. This is what we call CIDR, classless inter-domain routing. And this is just the same as saying my network address space is between 10.0.0.0 to 10.0.0.0.255. That's just the meaning, So this /24 is just saying, instead of me saying 10.0.0.0, to 10.0.0.255, I can just put a notation to say /24. And once I look at this, I would say this is, 255 address spaces, However, how many available IP address do I have within that 255 address space? We'll still talk about it. Like I said, that's why I need you guys to at least sometimes go through the Microsoft Learn documentation. It will explain most of these things because this is not a networking class. I might not be able to just, go in deeply. However, maybe I know we still have some classes, after now. Maybe we'll be able to explain, but just telling you that this is just representing the number of address, the number of IP address within this particular network. So how do we plan, like I've said, how do we plan our IP addressing? Just the same way you can see, just make sure that we do not have it overlapping. Now, and this is one of the reasons why we plan, our IP addressing. This is talking about the difference between the private IP address and the public IP address. So like I've said, within your VNet, within your premises environment, if you want your resource to be able to talk to each other, or if you want your devices to be able to talk to each other, you use what we call the private IP address, because your devices are going to, or your resources are going to be within a private network. That means not anyone that is not within or that is not connected to that network will not be able to see or will not be able to, there is no connection between the device, that is not within that network and devices within that network. That means in your homes, you can have maybe a Wi-Fi router, and that Wi-Fi router only serves, you people within that particular home. So someone else that doesn't have the password to that Wi-Fi will not be able to, connect. So there is no connection, between that particular network and, that device. So private network are only used to connect devices, within a particular network. So, and the only thing we do not need a public IP, because like I said, only when you want to access the internet, that is when we leverage on public IP addresses. But if it's just for us to connect our devices together, our resources together, then we'll leverage on, the private network. And that's why you can see for private IP addresses, resources in Azure, we can have resources in Azure talk to each other. We can have, on-premises devices talk to each other. We can even go ahead to connect, our on-premises with our Azure environment by leveraging on what we call the ExpressRoute, or even the VPN gateway, where, once we are connected, maybe to ExpressRoute, point to site to site, we are only able to connect, to that network. If we are not connected on the VPN, we will still not be able to access that Azure environment. But the public IP address come into phase when there is a need for us to access the internet or to access any public facing services. So if we have an application in our tenant or maybe hosted in one of the virtual machine residing in our organization, and we want users to be able to connect to this application, so then we need to assign or associate a public IP address with that machine that is hosting that public application, so that users, can connect to that application. And that's what you can see here. IP address, private IP address are used within the Azure Virtual Network and your on-premises environment. You can use VPN gateway, where we talk about the point to site and the site to site, or the ExpressRoute to extend your Azure environment network to the on-premises, or extend your network on the on-premises environment to Azure. Then for the public IP address, here you are leveraging on maybe the internet or any Azure public facing services. So how do we even create, our public IP address? These are just the same way we create our virtual network, the same way we create our, our resources in other resources in Azure. That's the same way we create this. The only thing is when you create an IP address, at least you need to assign this to maybe to a network. Now you can see we have the name. What type of IP version do you want to create? What type of SKU? Like what's the so when you say SKU is just like what's the type that you want to create? Is it going to be standard? Is it going to just be basic, network? So when you have the basic, there is a limit to what you can do. I think when you have basic, you cannot do some redundancies or something. Then we have what we call the dynamic and static. So for dynamic and static IP address, that means if I assign a static IP address to your phone, that means that IP address is never going to change. And that's what we call static IP address. So it's not going to change from .1.2 to .1.9. No, it will always be that .1.2. Then if that's what we do, for a server, because we do not want the server IP address to be changing. Because if it change, that means people trying to access that particular application that is sitting on that server will not be able to, because it has changed, except if, maybe we're using, because it's actually, they will not be able to. And that's why we want to at least make sure that we have, our IP address to be static. Then for dynamic, that means the IP address is going to always be changing. It's not static. It's not just one. It can change at any point in time. Now, so those are some of the things you need to look at. Then the tab, then the create. We'll take a look at this in the demonstration. Then where do we associate this IP address to on each of these resources? And this is what this guy is talking about. I explained that if you want to connect, or if you want to associate an IP address with a virtual machine, you need to do that on the network interface card, which is the NIC. And can you assign a dynamic IP address? Yes. Can you assign a static IP address on a virtual machine? Yes. And that's what you can see here. So the other ones are just, some of the other resources that we can leverage on also. Not all resources can, be assigned a virtual network. These are resources that work with network, with virtual network. So you have application gateway. Where can we assign that? There is what we call the front end configuration, and that's where we assign the IP address to. Same thing as the VPN gateway, which talks about the point to side, the side to side. When we create that kind of resource, where do we assign, or where do we associate that IP address to? And that's what you can see here. So this is just showing if we can assign dynamic and static. And as you can see, we can do that. The ones with asterisks is saying you can only use static IP address on a particular type of application gateway. So if you are using maybe the basic, you might not be able to use a static IP address. Or if you create a VPN gateway and maybe it's basic, you will not be able to use a static IP address. So static IP addresses are only available on certain SKU. Then let's talk about where do you associate or assign a private IP address. And this is the same thing we just looked at. So here you can see a virtual network, a virtual machine, internal load balancer. So you can see it's not a public load balancer now, an internal load balancer. Application gateway, you can use it for public or private. And that's why the application gateway, is showing up on the two side. So here you can see we have the load balancer, which it's a public load balancer. Yeah, and that's why they had to distinct it, saying you can only associate a private IP address with an internal load balancer. So this just explain if you can do the dynamic assignment or the static assignment. So our first demonstration for today is to create a virtual network in our portal, create a subnet, and create a public IP address. So let's take a look at that. So I opened up my portal already. So let's go to creating a virtual network. Like I said, you can start by creating a resource or clicking on create a resource, then look for networking, then come here and create a virtual network. But for me, I would not go through that route. I'll just, type in the name here. Oh, really? So virtual machine, virtual network. So that's what I want to create. So I have some virtual network because you have some virtual machine on there already and they need to be connected. So to create a new network, I just click on create. So just like I've said, you need to select the subscription. What resource group do you want to assign this to? You can even create a new resource group here by saying network test, and that will be selected. Then what's your network name? Network test. So where do you want to, what region, do you want this? Then I can go ahead, click on for social security, which we'll still talk about, in our upcoming course. Then IP addressing, here, you can see what I was talking about. This is /16. And for /16, you have more IP address than the /24. Now, what you need to know is the address space, since you are going to be segregating your network, you are going to be dividing your network into chunks. You are going to be dividing it into different subnets. You must make sure that your address space within that particular network must be greater than the one in the subnet, because if you want to divide one particular thing into 3, that means you have something very big. Then within that network, you can now start assigning different subnetworks. So you can see here we have 65,536. So I can use that to start creating different subnets. The first one will be 256, another one will be 256 until I get to the 65,536. And that's what the subnetting does. So I can go ahead to create, add a new subnet. And I'm going to do something now. And let's see. So here we can assign from 10.0.0.0.0 to 10.0.255.255. Now we've assigned 10.0.0.0.0 to 10.0.0.0.255. If I try to do something and I say, okay, so this is the address range, this is the size. This thing is trying to create a new one for me, but I will just say, no, I don't want it. I'm going to be creating it this way. It should start from 200. So this guy is telling me this thing is not a valid, a valid one. Instead, use something like 10.0.1. Something. So I want to do an overlapping, and I'd say, yeah. So if I try to do this, if it works on a normal day, because this actually belong to this network, it will not work. So one of the reasons why this guy is telling me this is not possible is the fact that your network doesn't start with there is what we call the network address. There's what we call the gateway address. We might discuss that maybe during, if we have a chance to have a networking class, then we can discuss this networking in full. But let me just create the subnet, and I'm going to just do 10.0.1.0, and this is going to create the next set of IP address range, and you would see. So the next one, I've created another 256 addresses, which you can see out of this one. I can create another one because this guy is saying you have up to 255. So I can create another one, say 10.0.0, .3, .4, .5, .6, .7, and that's how I keep, creating subnets until I get to use up all the 65,536 address space. So that's your, so you can see something here. This guy is saying address space here, has overlapped with another address space in your organization, which is your virtual, network test monitoring. I'm sure you guys saw this one. Let me just go to all the network that I currently have in my organization. If I try to create this network, yes, it's going to create. However, when I want to pair those networks together, when I want to connect those networks together, I will not be able to do it. So let me just go to virtual networks and you will see what I'm talking about. So this is the one is complaining of this test monitoring VNet. And if I go to the address space, you will see that I have the same one. You can see 10.0.0.0. That means if I want to connect these two networks together, I will not be able to do that. Okay, so here you can see the network 9377 FM, and also this one, is the same thing. I will try to do what we call a VNet pairing. You can see they have the same thing. This is, so if I go back to the network and I try to do a VNet pairing, and I add, so what does VNet pairing is? VNet pairing is just connecting, two networks together. So VNet 1, and I'm going to give this VNet 2, and this guy is telling me to select, the network that I have, because this guy and this guy are actually, they have the same virtual network. You can see what is happening. This guy is telling me, no, there is no way you can connect these two networks because their network address space is the same thing. And that's one thing you need to at least put into consideration when you are creating your network. So when you create your network, then you can start at least adding more address space. Let's say this is the network I've created. You can create a new, new subnet, and within your subnet also, you must make sure each subnet doesn't overlap. So if that is the case, we can go ahead to look at public IP address also. Public IP address is also a resource. If I do this, so you know that, like I've actually explained, you only create a public IP address when you want to connect to the internet. So you can create a public IP address, just the same way we've created, our virtual network. However, you want to be sure that you need a public IP address before you create one. So the good thing is when you are creating your virtual machine, or you are creating your application gateway, all those resources that leverage on, maybe a public IP address or network is going to create. That's why when you create your virtual machine, it's not going to create only your virtual machine. It's going to create your VNet. It's going to create an NSG for you. It's going to create subnet for you. It's going to create public IP address for you. So when you create a resource, that is dependent on other resources, it's going to create all those dependent resources for you. So that's that about the virtual network and subnet and public IP address. Now let's move on to the network security group. Do you have any question before I go ahead? All right. So for network security group, you know, what we are trying to do with a network security group is making sure, are we allowing the traffic to come into the resource, or we want to deny that traffic based on some rules. So a network security group, is a combination of rules, that is assigned or associated with our subnet or our NIC, which is the one on the virtual machine, to actually allow or deny traffic coming into our network. So that's what, network security group. So in summary, I would say is used for filtering traffic. So here you can see, we look at how to implement network security group. How do we even configure these rules? How do we create it? Then how do we determine how effective that network security group is? Now you can see here, this talks about the network security group is used to limit, network traffic to our resource within our network. However, you can only associate an NSG to a subnet or to a network interface. So you cannot associate an NSG to the network itself. So the network, if you want to do that, we add what we call a firewall. Now, I'm sure you guys might have heard of firewalls in the past. So we add what we call a firewall. But on the NSG, this is just talking about, this is explaining what we've actually talked about in the previous course, where I talked about the defense in depth. So on each layer, let's say you want to access your virtual machine now. On the network where your virtual machine is residing, we can have a firewall. Then on the subnet within that network, we can have an NSG. Then on the NIC of the virtual machine itself, we can have an NSG. So this is just talking about how we can actually, filter out traffic that is coming into the resource. So here, the network security group is a list of security rules that is used to allow or deny inbound or outbound traffic. So when we talk about inbound, traffic coming into the resource. And when you talk about outbound, so let's say something is requested by the user. Should we allow the resource to send out that particular, information? Then the outbound rule will take effect at that particular time. Then, when you create an NSG, you can associate it, with different subnets. It doesn't have to be one NSG to one subnet. So I can create one NSG and associate it with like 20 virtual machines. And that's what that is, saying. This is just the NSG. I'm sure you guys, if you have gone through all the labs for the fundamental, you'll have seen where you will implement a network security group, which is the NSG. Yeah, this is talking about the inbound rule. The inbound rule is, do we allow any connection coming in from the VNet, as in within the VNet? And that's why I said for private connection, resources are always able to talk to each other because there is this by default that is added to the NSG. So if you see all these 65,000, 65,001, 65,500, all these guys are by default. You cannot even delete them. They are default created by, Microsoft. You cannot even delete them. And why they created this is the fact that they want to make sure that resources within your network are able to talk to each other. However, you can override them. Override in the sense that you can create another NSG rule, maybe like this one, and the only thing you want these guys to do is to deny, inbound traffic from one virtual network to virtual network. So you can do that. So for NSG, you see all these 100, 6,500 that you can see that is under the priority blade tab. There is a reason for it. So when you create a rule, the lower the number, the higher the priority. So this one will kick in first, which is the 100, before all these ones will be checked. So because they have an higher priority. So if a traffic is coming in, the network is going to check which one is the one with the highest priority. And that's the one that will be allowed first before checking the other ones. So same thing, as you can see, we have the inbound rule, then we have the outbound rule also. Yeah, this is just talking about how do we determine, how effective our NSG is. So for NSG, when you assign an NSG, talking about the difference in depth, when you assign an NSG to your virtual machine, which is assigned or associated with the NIC card. Now, because there's an NSG also on the subnet, so for virtual machine now, you have two NSGs working. There is one associated with the subnet where the virtual machine is deployed. There is another one associated with the NIC card. To be able to allow traffic to come into the virtual machine, you must allow those two. You must have an inbound rule that allow that traffic on those two NSG. So if there is a deny, on one, maybe on the subnet, and you allow it on the NIC card, it will still be denied. If there is a deny rule on the NIC card and you allow it on the subnet card, it will still be denied. So you want to make sure that when you are assigning your rule, you are sure that this, make sure that you allow any connection coming into that resource on the subnet, and you allow it on the NIC card if it's a virtual machine. But if it's just other resources that doesn't use a virtual machine, let's say the application gateway, the same thing you do. Yeah, you must allow on the front end configuration. You must always also allow on the subnet. So this is just telling you, that the rules are actually independently evaluated, and that's what you can see here. They are independently evaluated. So it's not as if when you assign a rule here, it's going to check the subnets, and the NIC card at the same time. No, it's going to check them one after the other. So how do we even create? What are some of the things that we consider when creating an NSG rule? So we want to consider the source. What source? And that's why, when you try to access some websites, maybe from Nigeria, it will tell you are not allowed to access this particular website. So you can use what we call an NSG to block that traffic. So, and what they are saying is, what are some of the IP address that we do not want, to allow to come into our network? And that's what you can see here. So if you pick any, that means anything, any IP address, anybody should not be able to access. So if you do some IP addresses, so you are only saying some of these IP addresses that have actually, or these IP addresses that have actually specified here, if they are trying to access this particular resource, they should not be able to. If you only want to deny your IP address, fine. If you want to deny, let's say, a service tag in the sense that if you have, let's say, a particular service, like a particular resource, that any resource of this type should be denied, like every application gateway, regardless of their IP, they should be denied. So you can select a service tag, and that's what we call service tag. The same way we have NSG, which is assigned to the subnet of a network, we have what we call an application security group, ASG. This is also assigned on the application. So we can have an ASG. So this is assigned to when you have collection of workload, maybe collection of virtual machine or machine that is hosting a particular application. We can implement what we call an application security group, and we can assign those rules, to say when anybody is trying to access this particular application, these are some of the things that needs to be kicking to check if the traffic should be allowed or denied. So again, destination, we've blocked source. Then what about the destination? Okay, on my IP address, my application works on 15 IP addresses. However, I want to block some IP addresses. I do not want, this particular IP address, to be able to come in. So this destination, that means anyone trying to access this particular IP address should not be able to, or this particular resource should not be able to. And that's what, this is talking about. This service is just what we call protocols. So what protocol, where do we want to block this? If you do HTTPS, we are saying on port 443, we do not want anybody to be able to at least action this on this particular port, which is for, where we do our SSL, our secure server. When you try to access a website, they will tell you this website is protected because, you are leveraging, SSL, and that's why you will see HTTPS. If you will see some website that you want to access, and the only thing that we have is HTTP. That's on port 80. So all these things are something you will still, learn. Then we have priority. Like I've said, the lower the priority, the higher the lower the number, the higher the priority. Then same thing that I've actually said, the same way we have NSG, which is the network interface, network security group, is the same way we have, the application security group. And what this does is we logically group all these virtual machine that is hosting, a particular application. It might be hosting an application that might be one for the server, and you want to put everything, and assign a particular rule to guide it. So you want to define some rules to control traffic that comes into the workload of your application. And that's what we call, an ASG, which is application security group. Just the same way we have assigned our NSG to our network, we can actually assign an ASG to the workload that is hosting our application. All right, this is just, talking about the network security group, which, let's see. The same thing we've looked at. I'm just going to use one of the virtual machine that I have in the tenant to explain this. So if you go to your virtual machine, you can come down to, this is going to be on my, sorry, this is going to be on my, how did I forget it? Okay, so sorry. I'm on the virtual network, sorry. Yeah, so you can assign it on the virtual machine to, or on the virtual, on the subnet. It's not going to be on the virtual network. So now if I come down to, you guys will see, okay, here we have network settings. So under the network settings, you can see, what am I doing? Load balancer, network manager. This is my network manager, inbound and outbound. What's going on? This is networking, network settings. So sorry, network settings. And then we have, I'm so sorry. Okay, network security group. So under the network security group, you can see inbound security rules and the outbound security rules. If you want to assign anyone, so these are, looking at the overview, you can see the inbound rules, the outbound rule. Like I said, you can see I cannot delete this guy. Only this one that I've created. When you want to be able to remote into your virtual network, your virtual machine, you need to create, that priority. You need to create that rule to say, allow me to access, this virtual machine over RDP, which is remote desktop protocol. And that remote desktop protocol, every service in IT or every service on our server, has a port. So for RDP, we have port 3389. For HTTPS, we have port 443. For HTTP, we have port 80, and on like that. So do not worry about all those ports. You get to get familiar with them as time goes on. So here you can see, for me to be able to allow that, I need to create an RDP, security group, and that's what you can see here. You can see I can delete this one, but I cannot delete this one. They're graded out. So if you want to add an inbound security group, you can do that here, and just based on what we've talked about, you can select whatever you need to select here. You can see these are resources. If you select a service tag, these are different resources. If you select an IP address, these are IP addresses that you want to ban. If I put in my own IP address, this is what I need to, prevent from accessing this my resource. And the same thing goes with the network, the outbound security rule. So you can just take a look at this, play with it, add different inbound rule, add different outbound rule, and see if you can actually access those resources. So the last one for today will be the Azure DNS. And we talked about this DNS where I explained that this is domain name service or domain name server, and what this does is the one in charge of converting our domain name to an IP address. We understand English, we understand different languages. The only language the computer understand is um, the bits and bytes, which is the 0 and 1. So that's the only language the computer understand. That's why you will see the binary numbers 10011001. That's how we represent the language of the computer. So all these 192.168.0.1 that you can see, they are also binary numbers. If we start doing the 192, we'll still convert that 192 to something close to 110011, something like that. You understand? Or 011, something like that. So depending on the calculation. So it's just telling you that computer only understand a 0 and 1. So we are putting in google.com. How does computer now understand google.com? Since I've said computer only understand 0 and 1, that's where the DNS comes in. It converts that domain name, which is written in English, to an IP address that the computer understand, which is the 0 and 1. So you convert it and also convert it back, when pushing out traffic. So that's what the DNS does. It does more than that. Like when you want to verify your domain name, there are some things we call records. You can add a record. So how do we link a domain name and an IP address? Let's say I want to host my application on this server, and the server IP address that I've created in Azure is 34.1.1.9. And I want to host, dev devops.ng on that particular server, how do I now connect devops.ng and that virtual machine that I've created? So DNS server, helps to do that. So we have what we call a record or record. So that's where I will put the IP address of that machine on that DNS name, that I've created, on that domain name that I've created inside the DNS server. So that's where you do the connection to say if anybody try to access this domain name, they should be redirected to this server. If anybody try to access this particular devops.ng, they should be redirected to the server with the IP address 34.1.1.0 or .2, something like that. So, and that's where all these DNS records comes in. So here you can see the domain name. We spoke about the fact that when you create your Microsoft account, you are going to be assigned an initial domain name, which is going to be whatever domain name you've created that with .onmicrosoft.com. And when you try, if you have created your account, if you go in there and you try to create a user account, you will see that the domain name that will be assigned to that particular user is going to be a .onmicrosoft domain. So, but this is not a custom domain. Imagine, if I create my Microsoft account with DevOps, let's say Babafemi at devops.ng, what I'm going to get is Babafemi at devopsng.onmicrosoft.com. Imagine me, you want me to send you my email and I'm sending you Babafemi at devopsng.onmicrosoft.com. And it'll be like, why is your email that long? So we have what we call a custom domain. That custom domain is the devops.ng. So how do we now do this? So we need the DNS, to verify that I have this particular domain. And that's what you can see here. So if I put in my particular domain, once I click on add, I need to verify that I own this particular domain. How do we verify? We verify on the DNS server. So let's even take a look at this. So let's say I'm logged into Azure and I have a copy of domains there, some that I've verified, some not. So if I go to custom domains there under my Azure environment, you will see that at least I've verified this particular domain. This is the one that has been assigned to me initially because I created this account with Babafemi at it360ng.com. So Microsoft, created an initial domain for me, based on the email I've created that account with. And that's why I have my, I have it360ng.onmicrosoft.com as my initial domain. Then, because I do not want to be creating my, user account with, it360ng.onmicrosoft.com, I needed to, add a custom domain, and that's what you can see here. So I added a custom domain, and before I'm able to use this custom domain, I need to prove that I am the owner of the custom domain. So I need to log into my DNS server and add that, whatever needs to be added there for verification before I'm able to verify. So, or else, if that is not the case, I can just come here and add google.com and I'll start using it. And that's why you need to verify. So if I click on add this custom domain, this is going to ask me for which of the domain I want to add. And I say devops.ng. Okay, so you can add. That's not a problem. However, we need you to verify that you own this domain. So I need to go to where I bought this domain from and add this record. Once I'm able to add this record, then I click on verify. If Azure now notice that okay, this particular domain, this particular information has been added to the DNS server, then I'll be able to verify. And that's what this guy is talking about here. So for you to be able to add your custom domain, you need to have it verified. So to demonstrate, at least you need to demonstrate the ownership of that domain. And here in Azure, before you can start making use or leveraging on this DNS server, you need to create what we call a DNS zone. A DNS zone is where you have your, domain, register. So you need to create what we call a DNS zone, and before you can start doing all these things I've talked about, like if you want to point a particular domain name to a particular IP address of a server, if you want to add any record and verify that particular domain, you need what we call a DNS zone to be able to do that. And this is just talking about how to add those records. If I want to add that particular record that has been created for me, I need to click on the record set here and add. So there are different records depending on what you want to do. So we have the TST, the MX, for mail, the TST just for verification. We have the A record where we point our IP address to, the domain name. We have what we call other ones, they're just there, different records, different ones. So you can see the records. This is the one I talked about. This is the A record where at least you point a particular domain to a particular IP address. So the record set is a collection of records, within your Azure DNS zone. So this is what you can see. So a record. This talks about, how do we plan our DNS zone? How do we make use of the DNS zone? How do we point, or let's say there's a need for us to remove, any DNS information, any record that we'll add in there. So it's still, here you can see, like I've said, if you want to connect your resource, maybe your domain name to a particular IP address, you can actually do that. You can see from the DNS record, this is connected, the IP address of this particular virtual machine will be inside this DNS record. And you can see this same IP address is actually pointing to this particular subdomain. That means when people are trying to access this particular domain, the request will be made, to either this VM or this VM. So that's what we do from, the DNS record. So the demonstration, let's just do a recap and we can go back to the demonstration. So the good thing is, I just remember that if you are not even able to create the virtual account or your Enter ID account or Azure account, you can still make use of some sandbox, or some sandboxes under this particular course. Maybe I will find all those sandbox and send it to you guys. Okay, so this is the lab that talks about how to implement the virtual machine and the virtual network, and just the same thing I've done. You guys are going to be creating a virtual network with a subnet. You are going to do this using the portal. You are going to using the ARM template. It will give you that, feasibility to the ARM template. You are going to be creating a network security group and an application security group. You are going to also be configuring, a public and a private IP address, a public and a private Azure DNS zone. So this is just talking about, for public, you guys know that if we are exposing this to the internet, so if you have an application or a server that needs to be accessed from the internet, then you can point a domain name to a public IP address of that machine. your machine, your virtual machine will always come with a public IP address and also a private IP address. And that is what, that's what has been explained here. That is what was explained here. So here we have a private IP address. That means within your environment. So if you only want that application to be accessed within your environment, or that domain to be accessed within your environment, so you will point that domain, or you connect that domain to the private IP address of that machine. But if you want that application to be accessed from the internet or from outside the organization, then you point that particular domain to a public IP address of that machine. I'm sure you guys understand that. And that's what you have here. So you can do public or private, Azure DNS zone. Yeah. And this just explains what you need to do based on the architecture